Hi, this is day 7 of our sort of radical expressions, equations, inverse functions unit. And as Mr. Whalen alluded to in our previous video, today's lesson is going to be about solving. So I'm just going to go through a handful of examples about solving. You've seen solving of radical equations before in geometry when you were solving particularly for different radiuses in circles or spheres. And so we're just really repeating that and adding some of our solving natures that we've learned about in this course of Algebra 2. So as you can see, I just have this first question up here. We need to solve for x. And just like you would in any equation, the first thing you're going to do is just subtract your 4 from both sides. Oops, this is an x. And you're going to get the square root of x equals 5. And then we've learned about inverse functions, so we know the inverse of a square root is a square. So you square both sides. A square cancels out the square root because they're inverses, so you're just going to have x on this side, and you're going to have 25. So it appears that x equals 25. You should, whenever you're dealing with square roots, because there are things that we can't take a square root of and get real answers, remember those are some of our imaginary, you should always check your work. So is the square root of 25 plus 4, does that equal 9? And yeah, you'd get 5 plus 4, that does equal 9, and so our answer does check. So our answer to number 1 is 25. And again, it's just solving using our normal solving techniques. If you look at question number 2, notice that the square root sign is over both of those values. Here it was just over the x, here it's over the x and the 2. So your first step in solving this problem is you're going to have to square both sides. So you have to square the whole entire square root. If you square both sides, again, a square cancels out a square root. Those are inverses. So you're just going to have x plus 2 equals 25. And then from here, you're going to just use your normal solving techniques, subtract 2 from both sides, and x equals 23. You should check, again, anytime you're doing a square root problem, you should check. So you want to know, is the square root of 23 plus 2, does that equal 5? And so does the square root of 25 equal 5? And the answer is yes. So my answer to this second problem is 23. So our solving techniques are no different than you've seen in previous studies. Okay, so adding in sort of a new element is what do we do if you have a cube root? And again, we talked about this our first day of the unit. What's the inverse of a cube root? The inverse of a cube root is cubing. And again, the reason that we cube the entire side is because the whole function is cube rooted, not just the single x. So you're going to get x plus 2, and then you are going to have to know what 5 cubed is, and that's going to be 125. Again, then you subtract your 2 from both sides. X equals 123, and you should check your work. So is the cube root of 123 plus 2, does that equal 5? And is the cube root of 125 equal to 5? And the answer is yes, it is. And we're going to go over in just a second, how do you check that or type that into your calculator? Okay, so let's just talk about how do you again type in, oops, let me go back to my cube root problem. How do you type in the cube root into your calculator? We have talked about this before, but in case you forgot, there's this button on your calculator called Math. So I'm going to hit the Math button, and if you notice, option number 4 on your calculator is a cube root. If you push enter on that option, oops, sorry, let me go back. I'm going to get my calculator out of my picture window. So if I push enter on that, I get the cube root symbol, and I'm just going to type in 125, and notice my calculator tells me that is 5. So again, that's under Math, and it's your number 1, 2, 3, 4th option, and you can type in any cube root value that you want. Same thing would work for square root. Again, we usually use this square root, but notice that you could use number 5 Number 5 allows you, if you have an 84, you could type in any value you want. So I could officially type in 3 for a cube root and then type in 125, or I could do 4th roots, 5th roots, etc. So that's how you kind of walk through or check that in your calculator. But let's look at a few more examples. So let's look at question number 4. Question number 4, similar to what we were doing above, the first step that you want to do is first add your 18 to both sides. So you're going to get a 3 square root of x now equals 27. Notice there is the 3 being multiplied. I'm going to recommend that you divide by 3. And as you do that, you're going to get the square root of x equals 9. And again, you're trying to get rid of the square root, so you're going to square both sides. And when you square both sides, you're going to get x equals 81. And again, you should always check as you're doing these problems. So is 3 times the square root of 81 minus 18 equal to 9? Let's check. So is 3 times 9 minus 18 equal to 9? Is 27 minus 18 equal to 9? Yep, 9 equals 9. We have checked our work. So again, these first 4 examples are things that you should know from previous chapters or previous units, geometry, finding your radiuses, but it's just making sure you're doing your correct order of operations. My next few examples are using our techniques. It's going to look a little different and use some of the things that we learned in first semester in Algebra 2. Give me a minute. I'm going to space out these 2 questions a little bit. Okay, so question number 5, you notice that there's an x on each side of the equation. And so we're trying to solve for x, so typically we put the x's on the same side when we solve. But the difference here is this x is underneath a square root. So we're going to actually we're going to try to get the square root to go away first. So the first thing we're going to do is we're going to subtract 5 from both sides. So you're going to have the square root of x minus 3 equals x minus 5. Again, our goal is to get rid of square roots because square roots are hard to work with. So what we're going to do next is we're going to square both sides of our equation. Again, when you square a square root, those cancel out. Those are inverses. And now you just have the quantity of x minus 5 squared, which really it means it's x minus 5 times x minus 5. This is sort of a key step. When something is squared, it's that value times itself. Okay, so what do? You actually distribute. So you still have x minus 3. When you distribute, you get x squared minus 5x. That's this. And then you get another minus 5x and plus a 25. This one and this one. Next step would be combine your like terms on this right-hand side. And then the final step is to start getting x on one side. Get x together. Notice it's a quadratic, so we're going to get all the x's and we're going to set this equal to 0. So I'm going to subtract x from both sides, and I'm going to add 3 to both sides of my equation. So now it's going to be 0 equals x squared minus 11x plus, add those 2 together, 28. And so then you start to think, okay, this is a quadratic. All of my techniques that I've learned from first semester, how do I solve a quadratic, are now going to be used. So options for solving a quadratic would be, can I use the quadratic formula? If you remember that, you could use the quadratic formula. X equals opposite of b plus or minus the square root of b squared minus 4ac. All of that divided by 2a. That's a lot to remember. So another option is, can I factor? And typically factoring starts to become a little bit easier than memorizing the formula. So when it comes to factoring, again, we need something that multiplies to x squared. So that would be an x and an x. You want something that multiplies to 28. Okay, so when you factor, I'm just going to list everything that multiplies to 28. 1 and 28, 2 and 14, 3, 4 and 7, Nope, no 6, no. So those are my three options. I want it to get to a negative 11. So if those were both negative, I'd have a negative 4 and a negative 7. So in question 5, a lot of things going on here. First, we have to get rid of the square root. In order to do that, that's sort of this first column on the left. Then you get to a quadratic. Then you have to remember how to solve a quadratic. Once you have your two factors, you're just setting each factor equal to 0 and solving. So x could be 4 and x could be 7. This is the part where you really do want to check, and I'm going to check in a different color. Let's check in orange. So if I'm going to check, I want to check, is the square root of 4 minus 3 plus 5 equal to 4? So is the square root of 1 plus 5 equal to 4? Again, I'm trying to check this out. Is 1 plus 5 equal to 4? Oh, no. So this is not a solution. We would refer to this as an extraneous, it's a fun new vocabulary word, an extraneous solution because it's something we solve for but does not check. Then I should check my number 7. There's my ink. So again, is the square root of 7 minus 3 plus 5, is that equal to 7? Is the square root of 4 plus 5 equal to 7? Is 2 plus 5 equal to 7? Yes. So in this particular problem, 7 is my only solution. So a lot going on here as we start to solve radicals when they start to use techniques from first semester, which require us to factor, use quadratic formula, also to check our work. We have one more example I just want to walk through, so let's clear out some space and try the last one. Okay, so our last problem again, how do we solve for x when there's a square root of an x and there's not a square root of an x? So the first thing you have to do is get the square root by itself. So we're first going to add 7 to both sides. So you have the square root of 2x plus 15 equals x, again add those together, plus 6. Now I need to get rid of my square root. So now I'm going to square both sides. When you square both sides, this side just becomes 2x plus 15, and this side becomes x plus 6, x plus 6. Something squared is the value times itself. It's very similar to question 5. Now I'm going to distribute. I get an x squared, a plus 6x, another plus 6x plus 36. This side hasn't changed. I'm going to combine like terms. And then I'm going to set it equal to 0 by subtracting 2x and 15 from both sides. So I get x squared plus 10x plus 21, and now I'm going to need to solve my quadratic. I personally prefer factoring, so I'm looking for something that gets me to an x squared, an x and an x. Things that multiply to 21, a 3 and a 7 get me to 21, which means I set my factors equal to 0. So x could equal negative 3, or x could equal negative 7, and now I need to check. When we check, I just wrote out the work for checking for negative 3. I plugged in negative 3 into my original equation. So if I plug that into my original equation, I can see that, yes, this is a solution. I'm going to write out my work to check negative 7. When I check my negative 7, I plug that in, find out I get a negative 6 does not equal a negative 8. So again, we refer to this one as called an extraneous solution. Extraneous. So if you look on the answers, you're really going to be looking for these solutions right here. If you have any questions or concerns, consider, again, emailing your teachers, asking us for help, reaching out. But today's lesson is just on solving. Thank you.